Hello, students. This is Chapter 10, Part 2. Again, Chapter 10 is Extemporaneous Non-Sterile Compounding. So I'm going to finish slides, PowerPoint slides 30 to 60. Again, so this is Part 2. So we're going to focus this chapter on non-sterile compounding environment and equipment. So compounding environment should be clean, free of dust collecting, overhangs, physically separate from pharmacy, have refrigeration, portable water, hot and cold, and eye wash station. So if you're working in a compound pharmacy, if they have a clean room, this is usually way back in the pharmacy, separate from all other areas. If this is in an institutional setting, the compounding portion, again, is still separate from where you would actually normally do your IVs or any other type of compounding. And it's a no-brainer that if you're compounding, you want a clean area, you don't want any clutter. So this is just really a no-brainer. So now do we get to some of the tools. And again, I will send a video out, a YouTube video that will basically show you a lot better than what the slides are displaying. But here are some common measuring and compounding vessels and tools. So you have the mortar and pestles. So again, if you're on page 31, if you look to the right, the bowl, this one is actually a porcelain mortar and pestle. So the pestle is like the spoon-like device. The mortar is the actual bowl. And again, we use this basically for grinding purposes. If you got tablets and you need to convert it to a fine powder, you use the mortar and pestle. Very easy technique. You just basically break the tablets down until you see no chips or big particles until you get consistency of a smooth powder. And again, remember, this is found in every pharmacy. It's one of the oldest apparatus that's still used by pharmacists to this day. Back in the days when pharmacy first started, there are a lot of things that went away. At one point, the typewriter was very common. In order to be a technician or a pharmacist, you had to know how to type. But obviously, we don't have typewriters anymore. That's been replaced by computers. But back in those days, they also had a mortar and pestle, and we still have them even in 2020. Beakers and flasks. This is actually needed to measure mainly volume of different types of liquids or to actually mix them. The same beakers and flasks that you probably remember from your high school chemistry class. Ointment mills mixes and reduces the particle size of powders to make ointments or creams. Ointment slabs, plate or ground glass used for mixing topical compounds. So this glass plate right here is actually an ointment slab. And again, it's basically used to basically mix different types of ointments or creams. Measuring and compounding vessels and tools. So here you have the spatula. You see 3 different sizes. Spatulas are used to actually for a lot of different reasons. Again, we mostly think of spatulas as a counting apparatus. When we pour pills onto a counting tray, we use the spatulas to move them from left to right. But spatulas are also used when you're preparing ointments and creams, or you're transferring compounded products into a final container, because you basically use a technique with the spatula to actually mix different ointments together. Molds and presses. Molds for making suppositories are atrocious. I have to see if the slide has a picture of a mold. If not, I'll send one on a YouTube video, but it's not on page 32. Measuring and compounding vessels and tools. So the graduated cylinder, glass or polypropylene flask used for measuring liquids. So similar to a beaker, graduated cylinder is another measuring device that we use if we are actually mixing something that has volume or some type of liquid. They come in different shapes, conical or cylindrical shapes. That's like a cone shape, or most of them are just basically just a straight up um, vertical type of display. Nothing special about them. They range from anywhere from 5 mLs to more than 1,000 milliliters. Just all depends on your liquid measurements. If you're using a large amount, obviously you'll need a bigger one than 5 mLs, but they come as large as 1,000 mLs. Just depends on your volume capacity. Calibrated in both metric and apothecary units. So, we have two different systems. We have the metric, um, and we also have, so the metric is like the mLs and the cc's, um, liters, gallons. So it's calibrated in both metric and apothecary units. Little safety alert: when measuring liquids with a graduated cylinder, pipette, oral syringe, or dropper, always use the smallest size that can contain the volume to be measured. This is actually a good idea because this ensures better accuracy. Doing so minimizes your percentage of error in measurement. So, for example, if you wanted to measure something that was 4 mLs, you would definitely want to use a beaker or flask that goes up to 5 ml versus one that goes up to 100 mLs, because the smaller it is to the unit you're measuring, the smaller the percentage of error that you'll have. Just common knowledge. If you are measuring 4 mLs and you're using a 1,000 ml flask, that's a big difference. Chance of error there is greater because of the vast difference in the quantity. Sources for bulk ingredients. Just basically, if you're doing, in this case, 795, this is non-sterile. This is basically saying if you're doing non-sterile compounding, in this case, just refer to USP Chapter 795 for all the guidelines and practices. It'll let you know all the information that you need, storage requirements. So that's basically a refresher of what I was talking about in part one. Now, there's a little formula that measures percentage of error. So percentage of error is the acceptable range of variation above and below the target measurement. So you're not going to always get an exact 100% measurement. Some scales, and the more expensive the scale, the lower the error they can actually measure. So based on least weighable quantity of an ingredient, if sample is too small, the margin of error may be unacceptable. Compounded non-sterile preparations must have an error range less than 5%. So this is really the take-home measurement, take-home message I want you to know, that whenever you're compounding non-sterile preparations, the margin of error has to be less than 5%. Anything above 5% is not acceptable. And they use either one of these formulas. The percentage of error equals the error amount divided by the quantity desired times 100%. And remember, you want something at least 5% or lower. Actually, it should be lower than 5%. Or they may use the sensitivity range divided by the quantity desired times 100. And again, the greater the sensitivity range that it measures, the more expensive the scale. And you always want this less than 5%. So this is just a take-home message. So each scale has a least weighable quantity. Sometimes you see it abbreviated as LWQ. This actually comes into effect when a pharmacy is actually purchasing a scale. They have cheap scales that you can purchase for probably 30 to 40 bucks. And then they have more expensive ones. So usually pharmacies that are doing a lot of compounding, they may want to invest more so in a scale that can actually measure a small percentage error. Because if they just do the regular electronic scale, you run into the problem of weighing too small of an amount for a specific scale results in an unacceptable margin of error. So this is basically my take-home message rather. When purchasing a scale, but remember you as a technician will not be purchasing a scale. I just want you to know the concept. You will see different price ranges, and usually sometimes they will have a sensitivity range, and they'll advertise that this has a low sensitivity range, which means its margin of error, it can weigh very small amounts if it has a low sensitivity range. And again, if you are a pharmacy that does a lot of compounding and you're doing a lot of small compounding, or you're just doing various different sizes of compounding, like really small units, you will want to make that investment in a scale that measures very low amounts. And here's a practice tip: to maintain an acceptable error of less than 5%, no less than 120 milligrams should be measured on a class 3 balance. Okay, so this is the most common type balance, the class 3. And this is basically saying you should weigh no less than 120 milligrams to ensure that you'll have less than 5% margin of error. Electronic digital balance. Don't know if you've seen these before. You should have. These are pretty common in high school. So it uses a single pan, does not need the pharmacy weights. And this is just the steps of how to actually measure using an electronic digital balance. These are very easy. The one mistake that some people make is when you measure something on electronic digital balance, you have this blue device here is a weighing boat. So when you place the weighing boat on your scale, you have to remember to zero out the scale once the weighing boat is on there, because what happens sometimes is people will put the weighing boat on the scale and then add their measurement. But remember, once you put the weighing boat on the scale is going to take the weight of the weighing boat. So you always have to remember, once you put the weighing boat on the scale, then you have to zero out the scale. So the numbers should all be 0. Then you add your powder and get your accurate weight. If you don't do that, you're going to have the weight of the scale plus the weight that you're weighing out, and that's going to be inaccurate. And so these are just some of the steps, nothing complicated about this. You can just look over that as FYI. Class 3 prescription balance, again, capacity of 15 to 120 grams. Again, they do have more advanced and more expensive scales that you can weigh much less, but the class 3 are the most common type that you'll run across in the pharmacy. So just kind of remember those numbers, measures no less than 120 milligrams, and just remember the error rate has to be less than 5%. Measuring processes for liquids. So volumetric measurement vessels, like your graduated cylinder, graduated conical flask, pipette, oral syringe. Here's one mistake that people often make. Vessels should not exceed 80% more than a desired volume. Take measurement at eye level using bottom of meniscus. So the bottom of the meniscus is where you actually measure. Okay, so there's a little marking here. So here's your measurement, and there's your meniscus. This is what you actually read. Because some people are not sure if you read from the top of it or if you read from the bottom. Always read from the bottom of the meniscus, especially when you're doing like oral syringes. To get your actual measurement, you read from the bottom of the meniscus, not the top. Like here's another example here. If you look at the little syringe in the middle, you want to measure the little black portion that will eventually pull down. That's your meniscus as well. You want to measure from the bottom of it, not the top. So your pipette is a long, thin, calibrated hollow tube used to measure small volumes of liquids. This is it right here. So it's a really small amount. You would only need this if you're measuring very tiny amounts, like maybe a half of an ml or 0.6 mLs. You would use a pipette because it's a little bit more accurate and measures smaller amounts. Very easy to use. Oral syringe are very common. Everybody should have one of these at home. Used to measure small or large quantities, just depends on the size. Usually syringes or oral syringe, they come as small as 1 ml. The most common size is 3 mLs, but they have 5 mLs. I've seen them as large as 20 mLs. You should always keep one of these at home. Typically, a pharmacy will give one of these away for free. I mean, you can purchase them as well, but pharmacy will be glad to give you one of these away for free. I'm not sure if in your math class, and the reason why I say everybody should have one of these, especially parents. I don't know if your math class, if the professor actually went over this. If you're a parent, or even if you don't necessarily have to be a parent, even if you were giving yourself medicine, and you look at the back of the box, and it tells you to take 1 teaspoon. Just say you weren't feeling well, and you had to take some NyQuil or Robitussin, whatever the cough medication is, or the medication, and it says to use 1 teaspoon. There are a lot of people that still believe if they know they have to take 1 teaspoon, they'll just go in their kitchen and they will get a spoon that they'll eat cereal with, or a spoon that they'll use to eat soup or whatever, and they'll just fill that spoon up and take their medication and say, oh yeah, I just took my 1 teaspoon. That is actually not a teaspoon or equal 5 mLs. It's close to it, but not an exact 5 mLs. So the teaspoons that you have in your kitchen that you normally eat cereal or soup or whatever, that's not actually 5 mLs. It's could be a little bit more, could be a little bit less. It's not an accurate measurement. So that's why I always tell students they should keep one of these syringes at home for medicine purposes. Luckily, a lot of medicines come with the caps that have the actual measurements, or sometimes they'll have a syringe inside the package. But try not to get in the habit of always using the household kitchen teaspoon to think that's an equal 5 mLs, because you won't always get 5 mLs by using that teaspoon. These are far more accurate, the oral syringes that you get from the pharmacy. The process of weighing and measuring, just kind of look at these at your own convenience. They're a little step-by-step. Again, I'll send you a video of this as well. I think most of you actually know the process, but I will send a YouTube video with the directions as well. Sometimes when you see it, it's a lot better than actually reading step by step. So just kind of go over this, and I will send a YouTube video with the same process. Techniques for ingredient preparation and blending. You have 2 techniques here: comminution and blending. So the first one, comminution, is the act of reducing a substance to fine particles. This is similar to using mortar and pestle. If you got tablets and you want to grind it into a powder, this is a technique that you would use. Various methods depend on compound and master formulation record. Blending, kind of think of blending. If you have a blender at home and you're making smoothies or something, so it's the act of combining 2 substances, but it could be more than 2. So you put 2 particles together and you got to actually blend them together so they become one. Same technique. Using a blender is actually a more quicker way than actually physically mixing, because the blender is more powerful, has a motor, and it can combine the 2 products together. So kind of think of this as when you go and order a smoothie from somewhere like Starbucks. Okay, Now, there's a few definitions that I need you to know in compounding. And these are the techniques: trituration, levigation, pulverization, spatulation, sifting, tumbling. These are different techniques used in compounding, and try to be familiar with the terminology if you can. And the three most popular ones, but try to memorize all of them. The three most popular ones are trituration, levigation, and spatulation. Those are the three most common used in non-sterile. And here are the definitions of them. So trituration, and I'll send videos of these as well. So it's the rubbing, grinding, or pulverizing of a substance to create fine particles. And these are the most common instruments used to achieve trituration, which is the mortar and pestle. So this is like putting 30 tablets into a mortar, and you want to grind those tablets into a powder using your pestle. That process is called trituration. So you have a solid particle, and you want to grind it to a fine particle like a powder. Levigation. This is reducing the particle size of a solid when preparing an ointment by adding a levigating agent. So this one, you're reducing the particles as well, but this one usually almost always involves ointment or a cream, and you added just an agent to actually reduce the particle size. So this one, you would use a glass mortar or an ointment slab, and you basically are just reducing the particle size of that product. Real simple process. Again, I'll send a video on this as well. This one, pulverization is similar to trituration. You're using a mortar and pestle, but the only difference between trituration and pulverization is with pulverizations, you're adding a solvent to break it down. So you're adding some kind of liquid substance. Whereas trituration, you just have the physical tablets, and you just basically grinding them down to a powder. Whereas pulverization, you're doing the same thing. You're reducing the particle size, but you're usually adding some kind of liquid or solvent to help you actually reduce the particle size. And again, you normally use a mortar and pestle for that as well. Spatulation, real simple technique. This is when you combine and mix substances, usually two different ointments, or maybe an ointment and a cream, or it could be an ointment and a powder. But you're using the spatula to mix them together. So this one requires a spatula, and it requires like an ointment slab, because you have to place it on a solid particle. And all you're doing is like you're taking the ointment and you're mixing it with some powder, or you're mixing it with another cream, and you're turning your spatula up and down, and you're mixing them together. Again, when you see the video, it'll make better sense. Real easy technique. Sifting, this is not used too much in compounding, but the process is blending or combining powders using a sieve. So usually you have different powders, and you have this basic, I guess it sort of looks like a little, what's the word I'm looking for? It's this little mesh particle that actually blends them together, kind of sort of like a grinder, but the two powders get mixed together by being filtered through this little device, and that's how they actually blend together. Not a very popular technique, not one of the most common ones, but it's still a compounding practice. Tumbling is combining powders by placing them in a bag or container and shaking it. This is an easy technique, very simple. You probably did this at home while cooking something. All you're doing is basically, I'm pretty sure most of you probably have done this one way or the other. If you're like frying fish, or you're about to cook something that requires a special blend of powders, like you may just say, for example, fish fry. You have the fish fry powder, And just say you wanted to add some spice to it, or your paprika or some kind of seasoning salt. Some people will pour some of the fish fry powder into a bag, and then they may add some extra spices, and then you just seal the bag and you shake it up and you blend it together. It's the same technique. All it requires is a bag or a container. You put 2 or more different powders in that container, and you shake it up, and they blend well together. Very popular technique if you're frying food and you want several different flavors as a coating. So that's a real simple technique. So compound-specific delivery forms, powders, less common due to inaccurate dosing. Tablets, compression tablets, whey powders, placed in a dye, compressing ingredients. Don't worry about these too much. Rapid dissolving tablets, mixed powders, placed in a mold, bake in a convection oven, may include sweetener or binder. Don't worry about this slide too much. You won't be using this too much, so don't worry about slide on 45. Just kind of read over it. Capsules. So sometimes when you're making capsules, you can actually basically use your gelatin capsule, but sometimes powder or the actual drug ingredient goes inside the capsules, and this is if you were actually compounding it. So sometimes this actually requires a little simple math formulation. So they give you this example here. Nystatin powder has an activity of 100,000 units per gram. How many milligrams of nystatin would you use in each capsule if the final preparation is supposed to be 1,500,000 units per capsule? So this is what you're about to make. You're about to make 1,500,000 units per capsule. That's your final preparation. So the nystatin powder has an activity of 100,000 units per gram. How many milligrams of nystatin would you use in each capsule? So the steps that you use is this one. It's pretty straightforward. Hopefully you remember this from calculations. So the best thing to do when they have questions like this, you want to get it into the units that they're asking for. So they ask how many milligrams. So you want your units basically in milligrams. So by getting everything to the same unit is a quick way to actually get to your answer. So you can convert 100,000 units per gram to units per milligram. And one way to do this is you should know that there are 1,000 milligrams in 1 gram. So for every 1,000 milligrams, there's 1 gram. So if you have 100,000 grams and there are 1,000 milligrams in every gram, you should know that to get this to milligrams, 100,000 divided by 1,000 will give you the milligram conversion. Because remember, there's 1,000 milligrams to every 1 gram. So if you got 1,000 units per gram, if you divide that by 1,000, you'll get 100 units per milligram. Now you got to go to step 2, and this is where you do, hopefully you remember from calculations, your dimensional analysis. So you got Y milligrams, or this could be X, this could be any letter. This is your own known. You want to know how many milligrams are in 1,500,000 units. And that should be equal to 1 milligram per 100 units. And we got this conversion factor from converting 100,000 units per gram to milligrams. And then the rest is just simple cross multiplication. 1,500,000 times 1, you're actually cross multiplying. So on the left side, I am multiplying the denominator, which is the number at the bottom, by the numerator on the opposite side. So I get 1,500,000 times 1. So anything times 1 is always itself. So 1,500,000 will be at the top. and then you get 100 times 1 if you cross multiply the numerator at the top by the denominator on the right side. You get 1,500,000 divided by 100, and you get 15,000 milligrams. 15,000 milligrams is the same as 15 grams because there's 1,000 milligrams in each gram. And that's how you got your answer in this case. Now, here's some other type of compounding delivery forms. You got something called a troche. This is where the active ingredient is slowly added to a base over heat, stirred, poured into a mold to cool. I'll have to show you a video of this so you can actually see what I'm talking about. But they make vaginal troches, they have oral troches, but you can actually physically make a troche. Solutions, very common, so are suspensions. So solutions are prepared by dissolving the solute in the solvent by diluting existent solutions. So remember, solutions blend well together, always, which is a little opposite of suspensions. Because sometimes suspensions, you can make a tablet formulation into a suspension. But just remember the key difference between a solution and a suspension is suspensions will not blend 100%. They may for a little while, but if you sit a suspension down, they're going to separate into two different particles. And that is why you always, if you look on the right, the safety alert, regardless of their apparent stability, all suspensions should be dispensed with an auxiliary label stating shake well. So remember, suspension, sometimes if you make a suspension and you just put it on a table or a flat surface, it looks like it's blended together, but if you wait a couple hours, they'll slowly start to separate. That depends on the stability. Some suspensions have a stability where they'll stay together for a couple of hours, some longer, some less, but no matter what their stability, they will eventually separate. So you always want to put a shake well on every suspension, regardless. Ointments, cream, and lotions. This is a pretty much common compounding product. We use ointments, creams, and lotions, typically ointments and creams, especially when you're using the allegation where a doctor is requesting a certain percentage of an ointment or a cream, and you look on your shelf and you have two other strengths, but you don't have the strength that the doctor's looking for or requesting, but you can mix the two together and come up with the actual percentage that the doctor's requesting. And that's by using the allegation method. But one thing I want you to know about ointments and creams, just remember ointments, if you look at the name, ointments are oil-based, so they're usually greasier. Obviously, they don't mix well with water. Creams mix better with water. They tend to blend better together. So just know one is oil-based, which is the ointments. The other is water-based, which is the creams. And just basically know from this slide that ointments, cream, and lotions are typically common with allegation, where the doctor is requesting a certain percentage. You have two other strengths of that medication, but not the exact strength that the doctor is requesting. So you got to take a certain amount from each one using the allegation method to come up with the right percentage. Suppositories. Again, I have to send you a little video on this. If we were in the classroom setting, we wouldn't make suppositories. They're very easy to make. They just require you to have a gelatin-based suppository. This is the actual shell. So you buy these and they just come in this particular shape. But what's actually doing the job of a suppository is the actual ingredient. So usually you weigh out your substance, and then you typically have to add the ingredient into a mold. Again, if I show you the video, it'll make a lot better sense. Just the outer coating has to be able to melt at room temperature, because remember, suppositories get inserted rectally. So when they get inserted, they have to melt really quick. And then the active ingredient actually gets absorbed in the blood vessels of the rectum area. Same thing, they make rectal suppositories are the most common, but they make vaginal suppositories as well. Same purposes. You need some type of glycerin or gel coating that as soon as it makes contact with the body surface, it starts to melt, thereby releasing the active ingredient. These are pretty fun to make, little time consuming because you got to heat everything up and then you got to wait for it to cool, but they still pretty much a fun exercise. Again, I'll send a YouTube video of this as well to show you how they are actually made. This is one of those things that if you were working in a retail pharmacy, if another technician or pharmacist showed you how to make a suppository, you will get it the first time. Just very easy steps. Nothing complicated at all. Just a little time consuming. So let's see here. Measurements of a liquid solution should be taken at the bottom of the, so remember when you measure liquids, if you look at the device, it's always at the bottom of the meniscus, not at the top. Blank is more accurate than a graduated cylinder when measuring viscous liquids. So this should be an oral syringe. So remember, syringe, as I stated, are far more accurate than your household teaspoon or your household tablespoon. So remember, I encourage anybody, especially if you have kids, always keep an oral syringe at home, because that will actually measure out a actual 5 mLs or actual a true teaspoon. Your cereal spoon that you use is not actually 5 mLs. A blank and blank is used for mixing and grinding pharmaceutical ingredients. So this should be your mortar and pestle. Remember, mortar is the actual bowl. The mortar is the actual bowl. The pestle is the, I guess you could say the spoon-like or the hammer-like device that actually crushes the pills. UV protection containers. The UV stands for ultraviolet. So most compounded tablets and capsules must be stored in amber light protective vials. If you ever forget which ones need the UV protective containers, you can always look this up on the U.S. Pharmacy, United States Pharmacopoeia. All of this is online in case you forget. Again, if you were doing non-compounding, Chapter 795, which deals with non-sterile, will tell you everything you need, including the beyond use dating. All of this is online. So you really wouldn't have to really necessarily memorize this. You just have to know where to go. Technicians who probably work and do compounding every single day, this is probably second nature to them, so they probably don't have to always go to the website, but the website is there for you in case you need it, especially with the beyond use dating. Again, that's the date after which a compounded preparation expires. It should no longer be used. So remember, this is always shorter than a manufacturer created product, because the manufacturers use preservatives that extends the life. Stability criteria beyond use dating. Again, all of this is online. Just refer to the USP. This just basically tells you, and remember, these are estimates for beyond use dates. So refrigerated aqueous solutions or suspension, 14 days or less. Solid tablets and capsules, 6 months or less. Prescription with bulk drug ingredients, 25% of remaining expiration dates are 6 months, whichever is earlier. So these just give you estimates of when they should expire. Compounded label must contain the patient, similar to a regular prescription label, patient and physician name, name of preparation and date of compounding, internal ID or lot number. This is like the prescription number, beyond use date, directions for use, pharmacist initials, anything else required by state law. So it's really not much different from what needs to be on a regular prescription label, because a person actually has to take this home, and states have certain requirements of what must be on the label. So it's not much different from what's on a prescription label, because these are technically prescriptions. And then this is basically finishing this up. Labeling, final check, dispensing, and cleanup. At the final check, pharmacist dispenses compound and counsels patient on use. A lot of insurance companies don't cover compounded medications, or there's an extra fee with them. Most people know that if they get a medication compounded, they're going to pay a little bit more because it's a specially made product. Work area equipment must be thoroughly clean. Ingredients returned to storage areas. So every time you make a compound, once you finish that compound, you want to clean up all your apparatus, wipe everything down before you start on the next one. Proper cleaning minimizes cross-contamination, helps avoid potential allergic reactions. So you definitely don't want to compound a product, and then when you're done with that, start immediately on your second one without cleaning up all the apparatus from the previous compound. Wear proper protective garb during cleanup. That's a no-brainer. All of this is just FYI, just to let you know. So page 55, this just tells you the different references you can use for non-sterile compounding. The most common one that technicians usually use is the United States Pharmacopoeia, also known as USP. To me, that's really the only one you really need. But there are some other sources, but USP is the main one. And again, just remember those chapters. So you want to go to chapter 795 if you're doing non-sterile, 797 if you're doing sterile compounding, and in just in a rare situation, if you were at a nuclear pharmacy, you would look up USP Pharmacopoeia chapter 800 for hazardous drugs. And these are just a few more sources, just FYI, you don't have to memorize them, just know the USP is the main one. And that sums up everything. So that ends chapter 10. Again, just look for some YouTube videos that explain some of these processes that should be coming very shortly. Thank you.